For this tutorial, I'll be covering local code. And local code is just a piece of code that's only executed for one player, not all of them. And when code is done like this, it can be dangerous because it can lead to desyncs. Like creating a unit for only one player and not the others can desync that player from the rest of the players and crash their game out. Well, not crash the game out, but disconnect them from the game. However, local code is useful for things like displaying text to players, multi-boards, and a whole slew of other features. You might have a multi-board that's only displayed to one player. You might have 12 different multi-boards all running off of the same multi-board with different options for each player. You can just make it a whole lot easier and save a whole lot of memory by using local code. And it's also useful, very extremely useful for syncing data. You might read data from a player's hard drive. That data is only on that one player's hard drive, so you need to use local code in order to read it because the other players aren't going to have that data. Then you would have to translate that data from one machine to all the other machines. You'd have to broadcast it, and that broadcasting is again local. The other players would be waiting for that machine to come broadcast its code. The primary native that's used with local code is the getLocalPlayer native, and as you see, it returns a player. This actually returns the player of the current machine it's run on. So if I'm on a machine and I'm red, I'm playing the game, getLocalPlayer would return 0 for me, player 0. The player across somewhere else, maybe in another state or whatever, they're playing the same game I'm in and they're blue, getLocalPlayer will return player 1 for them. So it returns a different value for each player. It returns the value that the person is actually playing as. So if someone had the name like let's say function, how about a struct tester? We could do a simple little ban program instead of kicking them out of the game, logging them out, or crashing their Warcraft 3 or something, by doing something with local code. So we can go if getPlayerName getLocalPlayer equal fag or something, or how about evil? There we go. Then call create unit getLocalPlayer HPA 00270, call set unit X. In fact, we could even be more evil and completely crash them out. There we go. And if. And this code right here is only run for the player that has the name evil. It's not running for any other player. In this player ID, usually getLocalPlayer is always used within getLocalPlayer blocks because you can only modify the local player. The most you'll see it though is with display time text to players. So normally you pass in a player, but you can display that same time text to all players instead of using a loop by using getLocalPlayer. How about 0060? Hello. There. And then you can do getPlayerName getLocalPlayer. And now actually go hello there nickname. Whatever their nickname is, it'll say hi to them. So it's a different message for each player using that player's nickname. You can do other things like using that player's hero and so on. You can just display personalized messages very easy with one line of code instead of doing a loop. And that's really all there is to local code. If you want to run code locally for one player, this would run code for player 0. The thing about text tags is that text tags are also local. So you can create local text tags for a player. And the thing about text tag systems is you can only have 255 text tags, so a good text tag system will create text tags locally for a player, while having global pointers, so the struct instances, that all players can access. The handle will be null for every player except for the one player it's supposed to be showing to. You could actually have a boolean here, so go if true, then run this code for local player, and this boolean could be if local player equal player 0 or get local player equal to player 1, or you could do is player enforce or whatever you want to do, and it will run the code locally for that one player. But again, you have to be careful because this local code is dangerous and it can cause desyncs within the game if you're not careful with it. Also, if local code takes too long to execute or the thread crashes, then you're really screwed. If that thread crashes and it didn't crash for the other players, then you have a whole slew of errors and the player desyncs from the game that the thread crashed for. If the thread, or rather the code, took way too long to execute and the player's falling behind the others, the little waiting for players drop box will pop up for them and it'll stay up until the code finishes. And if it doesn't finish in time, if they take more than like a minute to do it and they're way the heck behind, they'll be dropped. And that's a challenge with things like syncing up data from one player to another or to all the other players, or like reading tons of data. If you might have a 3 million line string of data and you're reading all that in and converting it to integers and sending that out in packets to every other player, that's going to take a really long time. So you have to have a way to keep the player caught up with all the other players that are waiting for that one player. If you just try to do it all at once, and you have things to keep the thread from crashing like trigger sleep actions, that player is going to fall behind. And in fact, if you do a trigger sleep action within local code, that player is going to desync because that thread's going to go to sleep for that player alone and not the others. You have to be extremely careful with local code. But they're useful for things like UIs and so on, so I do recommend you use local code. Just thoroughly test if you're doing something you're unsure about, like if you think the code might take too long, the thread might crash, or something like that.